As a skateboarder goes by, hello. My name is Robert. I founded yaymath.org. As the skaters go by, man, it's all good. It's free. Yeah, hang out and learn some math. And this is presenting Teach on the Beach. I'm the teach. That's the beach, right?
I like it.
And today, while connecting to this beautiful, iconic setting, we're going to share the love of math. You guys can hang out if you want to see. You want to step over to the side so you can hang out with us. Yeah, we're going to do the math. Let's do it. Let's do it. We're going to be talking about being rational. So have you heard of these numbers, rational numbers in school? Do you know what rational means? What does it mean? What's rational mean?
Rational number.
It's okay if you don't know.
What's a rational number?
You know, I'll say I'm gonna in their defense, this is what happens. Like they go to school and the freezing up is one. So first of all, I'm just here to hang out with you. There's no crime, no victim. You know, we're just hanging out. And another thing is like we just go forward without even defining this word. All right? So let's just define this word for you. This word, rational numbers, are basically all numbers that you could think of with decimals, fractions, 1.5, 1.55, 1 over 3, and even the whole numbers too, like 1, 2, 3, 4, 5. These are all rational, okay? The only numbers that wouldn't be rational, let's say, are things like pi. Avogadro's number, right? He has super small numbers that go on off and forever.
Yeah.
Pi goes on and on and on and on. So square roots go on and on. So we're just thinking of numbers that you could write down like percents and decimals and things like that. All right, so let's say I had 1/5 of a number plus 2/5 of a number, all right? Started off light. Call it out, what is this? 3/5, right, all right, we're for 6. Say hi to Joey. What's up, Joey? And this is LJ.
Hi.
Where are you guys from?
Germany.
Germany and?
LA.
LA, welcome. Yeah, okay. Rocking from abroad and local.
Yes.
Okay, thanks for being here. So what is this, Joey?
It was at 3/5.
3/5, that's right. Because you know what you're doing? You're adding the same type of thing, right? 1 apple plus 2 apples is 3 apples. 1/5 plus 2/5 is 3/5. Rock and roll, you got it, okay? So then it gets a little cray-cray when we do this, 1/2 plus 2/5. Now, can you smash together 1/2 and 2/5?
No.
Not really, right? Right? So it's like, it creates a bit of an obstacle
Yeah.
when the denominators are not the same, right? So they called it in schools a common denominator, but we want to add the same type of thing. Apples to apples, oranges to oranges, fifths to fifths, and in this case, we're going to make these the same denominator,
Yeah.
okay? So I'm going to draw this before we actually talk about what the denominator is. Just say yo or hi if you think you already know what the denominator is. You don't need to give it away. Just put it up and say, hey. Okay, so you're still thinking? I see you thinking, young man. That's you, yeah, you. Yeah, yeah. Do you know what the denominator is? You could say yes or no. Yes. Okay, cool, rock and roll, rock and roll. Ladies, young ladies, do we know what the denominator is? Nice, they know. Okay, so I'm gonna show why we get that number, okay? Here comes chocolate. All right, yeah, chocolate, right? Is that half of chocolate?
That's half chocolate.
All right, shade it. Shade the half of chocolate, boom. Chocolate bar number 2. 2/5 of the bar, homie. There we go. Okay, so let's see if I can divide this into fifths if I'm a boss. 3, 4, 5. Not bad, right? Not looking for a Picasso, but just looking to do the job. 2/5, how many am I shading?
All of them.
2.
Oh, sorry, 2 of them.
2, that's right. I will, technically, Joey, I am shading 1, and then I'll shade the other one.
Okay.
Rock and roll. So here we go. So 1, so you're right, and now 2. So we face the same dilemma. We can't add these. We can't add these until we make them all the same denominator, right? Young ladies, hold it up with your hands. What's the common denominator? Yeah, hold it up. Bravo, it's 10. Give them a hand too. Rock and roll, that wasn't so bad. So we have to turn halves into tenths.
Yeah.
Joey, LJ, this is gonna be on you, all right? So if we want these 2 pieces to become a total of 10 pieces, how many do we cut this into? And how many do we cut this into? 5 each, well done, well done. So we're going 5 each. Let's go blue. The pen is blue, liar, liar. Okay, so here we go. 5 on this, so get some angle here. 1, 2, 3, 3, 4, 5. There it is. And then we'll do it again, just for fun. Just so dot it. 1, 2, 3, 4, 5. Okay. So now 1/2 became how many of these tenths? 5. Well done. So let's write 5/10 in this place. 5/10, like a boss. All right, and this is a little difficult question. LJ, this one's yours. If you have, there, that's the spirit. She's like, oh, great. Oh, great. So if you have 1, 2, 3, 4, 5 blocks, and you want to turn them into 10, each cuts how many times? In half. That's right. Well done. So we're going to cut these in half. Chop, chop, and then cut those as well. How many tenths are there?
4.
4. Well done. So that's 4/10.
I like the
Yeah,
approach.
come hang out with us if you want to do math. Not bad, right?
Yeah.
So how many total tenths do we have?
9.
9. Well done. 9/10. Good job. 9/10. That's basically the idea, is establishing a common denominator. Now, the chocolate's cool. It's a good image, you know. It's good both mentally and spiritually, right? And so now that we've understood the picture of turning halves into tenths and fifths into tenths, we could talk about what we do numerically to establish the same denominator. And that's pretty much this idea over here. What do I need to multiply 2 by to get to 10? Times 5, which is what you said, right? And what do I need to multiply 1 by as well? That's right. So whatever you multiply to the top, you have to multiply to the bottom. So what do you multiply top and bottom here? 2. 2. That's right. And that's the process of establishing a common denominator. It's like, what can they both multiply to make? Our young friend over here said 10. Hey, welcome. Welcome. If you want to hang out and do math. This is our time together. Yeah, so that's the way. It's to establish a common denominator. So let's make it a little more challenging. You up for the challenge? Yeah. Okay, let's do it. All right. So what can 2 and 3 both multiply to make? 6. Right. They could both multiply to make 6. Multiply. So you know what's fun is you actually go like this. So I'll give you some ways to write it down. 6 here. 6 here. What must we multiply 3 by so that it becomes 6 times 2? So do you agree if you multiply the bottom by 2, multiply the top by 2? Rockin'. What? 4. Well done. Let's do this one. Top and bottom by what? 3. Bravo. Joe, is this okay? Is this okay for you? Yeah, it seems like you're totally comfortable. Yeah, you're comfortable with this.
7/6.
7/6, right? So oftentimes in a lot of schools, they're comfortable leaving it at 7/6, you know, as an improper fraction it's called. Or you could actually turn it into what's called a mixed, right? Friends, yeah, how many times is 6 going to 7? Once. Leaving how many sixths remaining?
1.
1 left, that's right. So that's a way to do that one. Okay, either one's fine, 7/6 or 1 1/6. Okay, but usually this is like what we use on the street. Yeah, you wouldn't say that I ate 7/6 of pizza. The kind of people would be sort of mad at you. You would say about a little more than 1. You know, that'd be a fair thing to say. I wouldn't mind saying 7/6, but you know, that's me. Yeah. Now we're subtracting 3 of something minus 4 of something. So if I had 3 of something and I took away 4 of that same thing, friends, what do I have? -1. Very good. Were you thinking it, boss? You weren't? Okay. Where are you from? England. Yeah, that's why I heard it. I heard it of maths. Yeah. Yeah, like you call it maths, we call it math. But it's still the same thing. Really, though, what we're talking about is 3 minus 4.
Yeah.
3 minus 4, all right? And 3 minus 4 is just below 1. Does that sound okay? Yeah, if you have 3, let's say you go like 3 feet above ground, and then you go down 4, right? Yeah, so that's -1 over 6, the same thing. All right, well done, good job. Let's do several more. 4. 4 more, yeah, 4 more. You got gas in the tank? Okay, good job. 20 and 5. 20 and 5. They need to have a common denominator too, right? What's the smallest thing that 20 and 5 can both multiply to become?
20.
That's right, 20. So the reason I picked this problem is that sometimes people say 100. Is it true that 20 times 5 is 100? Yeah. That 5 20s is 100? So you're welcome to make it 100, but what we can do is try to think of the smallest thing that they could both multiply to become. That's awesome. You guys, thank you for hanging out and learning math. If I said yay math, would you repeat it? Try it. 1, 2, 3. Yay math! Yeah, there you guys are nodding. Very good. Yeah, I feel the vibes. So you're right, it's 20. Good job, Joe. All right, so is this one already done? This one's already done, right? What do we multiply this, friends, top and bottom by to get it? 4. Bravo. So times 4, times 4, times 4. This becomes what over what? 8. 20ths is correct. 13 minus 8 all over 20 makes 5. That's right. That's right. You feeling this? Come join. Come back. Do you love math? No?
I like numbers.
You like numbers? Okay. Hang out for 2 minutes and maybe we can change your mind just a little. Just a little. Just hang out. Just hang out. You're welcome. Thanks for hanging out. All right, so that's 13 over 20 minus 8 over 20. Joe, you said it well done. That was 5 over 20. And again, would you call your friend and be like, I was so hungry last night. I ate so much pizza. They're like, how much you eat? They're like, 5 20ths, man.
Or you can say, I ate a quarter.
I ate a quarter. That's right. That sounds a little better. Yeah, you know it's a quarter, right? It's like, who wants to live that way? Like, oh, like, got to make it 20ths. Got to make it right. You'd be like, man, stop using fractions like that. But yeah, the real reason that this is 1/4 is that you can divide top and bottom by what? So notice here, we multiply top and bottom by 4. If we're permitted to multiply top and bottom by 4, we're permitted to divide top and bottom by 4. I see you smiling. Come back. Math time. Okay, he doesn't know I'm talking to him. There we go. Divide by 4, that's right. Becomes 1/4. Well done. Let's do the same thing over here. 2/5, we agree, becomes 8 over 20. We did that upstairs. 8 over 20. All right, $13 plus $8. You like numbers? What is 13 plus 8? Well, I'm talking about 13 20ths. Thank you for clarifying. 13 over 20 plus 8 over 20.
Yeah, okay, that's 20.
21 over 20. That's right. 21 over 20. Again, I want to address a common mistake. Sometimes people think that the 20 needs to change, like 40 or something. It's not. We're adding the same type of thing, right? 13 of something plus 8 of something is 21 of something. And then LJ, this one's yours, right? Your old friend. We're going to turn this into mixed. So we'll call this improper. This is an improper fraction because this is, yeah, you gave it to her at school.
Sorry,
it's okay. No, you know what? That's what he did because he loves her. He's giving her the answer, which is nice, right? But I believe that like we could extend the love by like giving her a chance to think it through, right?
Okay.
Right. But I agree. I know what you were doing. It's a beautiful thing. So we only ask ourselves, how many times does 20 go into 21?
Yeah.
How many?
Well, it goes 20.
Yeah, good. You're stepping forward. How many times does 20 go into 21? How many 20s can you fit inside 21? There you go. You corrected your answer. Good job. Good job. Well done. 1. And we're left with how many 20ths? 1 more. There's 1 more 20th. Can I show you why? Can I show you why? And I appreciate that you're committing. Yeah, it's okay. This is the process.
I hated math.
Yeah, she said it in past tense. I hated math.
I hated it.
Good job. You hated math? If you
I don't take it
want to
anymore.
stand right here so you can let them see the board?
Okay.
Awesome. So here's all it is. What's your name?
Melissa.
Melissa. Hey, Robert. Nice to, awkward, like 8th grade. It's like, oh God. Oh, yeah. Middle school, back to middle school all over. Awkward moments.
You're bringing me back.
Oh, yeah. So do you agree there's 21 20ths here?
Yes.
There's these thing called 20ths. How many of them do we have?
Right.
What's up, boss?
What's up,
Robert.
man? I'm
Hey.
Evan.
Hey, Evan. Nice
Yeah,
to
so
meet
we
you.
have 21 20ths. So
That's
there's-
right.
It's not 1 left. We have 1 20th left.
We have a whole and we have a 20th left. I'm going to show you.
1/20th.
1 and 1/20th is the answer. This is not done. I did that on purpose. I'm not done with this problem because I'm hanging with Melissa and now Evan. Yeah. So here's why.
Join me over.
Check it. Yeah. So we're asking Melissa, how many 20ths do we have? One more time, Melissa, how many?
1 and 1/20th.
That's true. That's true. You're ahead of me now.
Okay.
Now that you get it, I'm glad. Let's bring it back 10 seconds ago to that person who didn't get it.
Okay.
Embody her.
Right.
Awesome.
There was 1/20th.
So how many total 20ths do we have originally?
1.
How many 20ths do we have?
So 20,
21.
21.
So what if I just decided to split them like this? There.
Yeah.
Is that cool?
Yeah. So that's
All right, that's right. So 20/20ths is how many?
It's 1.
One.
Yeah.
Yep, one. Good job.
1/20th.
So that's 1. And then how many 20ths remaining?
1.
1/20th. Good job. Back, fast forward to your present self, and you're right. It's 1 and 1/20th. Fantastic.
Good.
Okay, that's basically the idea. So happy you.
Been my math teacher.
I am now. We're learning now together, right? All of us in this beautiful Friday day. Did you fancy that you were going to be learning math today? No.
what's going to happen.
Who knows what's going to happen today on Venice Beach? That's right.
I'll try.
You want to try? Hit that. Yeah, dude. Perfect.
Okay.
Go with the blue. Go with the blue.
with the blue.
Go with the blue. Hit that. So yeah, it is a common denominator of 24. You're right. Times 3.
Sorry, you do this, right? 3 times 3. Oh, sorry, 4. 4
Times 4. Good correction. I got you. Teach your hands.
Sorry.
No. Okay, so no need to apologize, right? Should he apologize for getting it wrong?
Now,
Never.
Learning.
It's learning. It's learning. Yeah. Yeah. No apologies for getting it wrong.
plus 4, 24.
Got that. Good job.
Equals 19, 24.
Bravo. Give him a hand, everyone. Good job, Joe. Well done. I'm so happy that you actually volunteered to do it. That's right. And you, by the way, moment, did you remember she said, I hate math, and she walked forward.
Hated math.
Hated math. Thank you.
Past
She remembered the
tense.
past tense.
tense.
She hit me with the past tense.
Yeah.
But then you walked
She
forward.
loves it now.
You walked forward. I want to it is intriguing, right? And if we could just remove the burn of getting it wrong, as if we're going to be mad at you for anything, right? We would never do that, and let that be a lesson for all learning, you know?
For sure. No judgment.
No judgment. That's right.
When you're adding a negative,
Right.
So negative plus a negative.
a cause.
You're thinking multiply. You're thinking multiply. So when you multiply two negatives, that would become a positive. But what this is, can you picture this as like, it's very bright. Can you picture this as like negative $2.90?
But you can also think about this as like adding without the negatives and just adding the negative at the end.
That's true. That's true. But we have to talk about why. Why that is. Is this a surplus or a debt?
Debt.
That's a debt. Is this a surplus or a debt?
Debt. We're combining two debts.
We're combining two
And
debts with a higher debt. That's right. We have a bigger debt, but the word bigger is wrong.
Yes.
Because it's like, it's really small. We have a lack of money, in other words. That's right. You could think of it as like, yeah, right? I should have picked more positive numbers, but then we couldn't engage people with the thing. That's totally right. That's totally right.
16.3.
Yeah, another way to think of it too is like, would you rather have negative around $3 in the bank or negative 13 in the bank?
Well, yeah.
Which would you rather have?
Neither.
Neither is the right answer. But then like some people ask, which is the bigger number? Do you know what the bigger number is? What's bigger?
-3.
That's right. Negative 3 is bigger because it's closer to your goal of surplus. Right, so we have two debts added together. So look, you can do this in traditional ways, right? There's traditional ways, and then there's like sort of more intuitive ways. So we agree we're gonna add these, and like Evan said, we're gonna make it negative.
Yeah.
So let's do it traditional ways. 4 plus 9 is 13. This is down in Germany, they do it like this way?
One is up above. We put it here.
Where you put the one? Oh, you put the one down here. That's so interesting to know. So like we're learning how they do it abroad. They put the one down here. So we put the one up here. So I never knew that before right now. So that's really special. So that's 6 decimal drops. You'll notice that I align the decimals. That's really important when adding. And then we add a 1 to 0 technically, and that's negative 16.3. All right, and then a little more fun way to do it as we conclude would be just thinking of like negative 2 plus negative 13, right? Because this is what we're doing in life. We're trying to pick these types of numbers. Welcome. Okay, can we finish this problem and then we'll do the question? Is it about this or something in general? Okay, in general, I'd love to talk to you about it. Yeah, but hang out. So negative 2 plus 13 is what, friends?
Negative 15.
Negative 15, got it. Negative 15. That's called classroom management. What just happened? Or classroom leadership, you could say. And then you have Nice.
That was for you, man.
Nice. Oh, right. Rock and roll. Yeah, it says leader. Yeah. Yeah. Product placement. Good. Thanks, dude. Thank you. So we got negative 15 in the house. And then we have negative 40 cents and negative 90 cents. So essentially 40 cents and 90 cents. What is that?
$1.30.
$1.30. Bravo. $1.30. So that's $1.30. 1.3. And then to me, in my mind, it's a lot more manageable to add 15 bucks and $1.30. It's like it's more invitational to add 15 and $1.30. And lo and behold, we get that negative 16.3. Sorry for the graffiti. We are in Venice, so we're good. Yeah.
Very nice.
All right. Any questions?
No, it's
Thank you for spreading
well
it.
explained.
Thank you. Thank you. You want to do a group hug? Group. Yay!